you are taking a look, factoring the larger one. So like I just said from that 7 worksheet, to factor a polynomial with more than 3 terms, we're going to always be regrouping. So up to this point, we've either had binomials or trinomials. We factored out a greatest common factor, or we've tried to factor our trinomial maybe with 2 parentheses. So it means breaking down a larger polynomial into smaller parts to make it easier to factor. So that is our goal as we are doing this. In your textbook, if you are looking, it's 8-8. If you need to look at more notes or more practice or the assigned quizzes that I have on Pearson. So we're going to start with the problem, and you notice it is not, we do not have, as we look at this, a greatest common factor. So that's the first thing we are looking at. Then it says pair up the terms of your polynomial. So they paired them up with the first 2 and the second 2. So do you see how I said this is kind of like that problem we just did in number 11 where we did the AC split? Because now we're pulling out our greatest common factor first and the greatest common factor of the second part. So they factored that out, 3n squared, n minus, so it looks almost like what we were doing before, except they give us a trinomial. And what's different about it, notice, is that you have this n squared. So this is n minus 4 that they both had in common, and this is 3n squared plus 2. Now, sometimes you will get a problem, not in this case, but sometimes you will get a problem that will have something like this. You might get n minus 4, and then it might be something like, so another example, and you might have something where it comes out with 4n squared minus 9. And you get it factored to that point. And if you leave it like this on the test next week, I have to mark that wrong. Because you have just factored that big thing down to a simpler one, and I agree with this. But if I was looking at this problem, I can keep this n minus 4, but how do you factor 4n? This is the difference of 2 squared. So now I want to recognize that I see more than just this one. Can't be factored any further. But this one, 4n squared, oh, that's the square root of 4n, that's 2n, and 2n. And the square root of 9, that's a plus 3 and a minus 3. And then I have this whole big answer. You're not going to have many of those, but anytime you can factor, you have to factor it all the way. So if you get something and then there's still the greatest common factor, you got to pull that up. So let's take a look at this next one. And I just wanted to give this as an example to make sure you know sometimes this is where you stop, but other times you have to go a step further. So if we are looking at this one, our greatest common factor as we start out on this one should be, Whitney, in that first half, what's your greatest common factor? 2 and anything else. And the smallest power of t would be t squared. Then, Micah, I'm going to be left with 4t plus 7. And Sanjay, from that second half, I'm still going to keep my plus. So some of you are trying to make this into a multiplication. Plus what, Sanjay, is common here? 5. Leaving us with what? 4t plus 7. So it's kind of like what I said, yes, with what we did with that AC split. So I'm pulling it out, and if I'm looking at that, Caleb, I'm going to have what?
4x plus 7.
So we'll go 4t, but I agree, you could have an x there. And then my second parenthesis is going to be what?
2t squared plus 5.
2t squared plus 5. We have no greatest common factor here, no greatest common factor here. If you're done, that's it. That's what you're going to be doing. All right. Okay? Now, I always will have the directions that'll say factor, but this whole factor completely means factor until it cannot be broken down into smaller or prime factors. So, try to look for any common factors first. These are the hints. After factoring, look for special patterns. So, what are our special patterns? Well, that a squared plus 2ab plus b squared, that was one. And the only thing different is this could be a plus or a minus. That's one of our special patterns. The other special pattern is a squared minus b squared. So if you can see some of those final patterns, as your final answer, you need to look if there's any common factors that can be factored out. So we are going to take a look, And as we look at this whole thing, I have 6, 9, 12, 18. If I'm looking at all of these, what do I notice they all have in common? They all have, so we want to factor out both of those. So as you start this one off, we are starting with factoring out that 3 and h, okay? So we're going to start with that. So always start with your prime factors and greatest common factors. So 3h. Leaving us, Abby Medler, start me off with what? 2h to the third. Dylan, keep going.
And
3h to the second. And Jack? 4h. And Mallory plus 6. So I have this 3h. And now I put a bracket. You can use a parenthesis or a bracket. I am now looking for my greatest common factor, Taylor, of the first two. 1h. And I don't care if you put 1h or if you just put h. Okay? So when I factor out that 1h, I'm left with
2h squared plus 3h.
2h squared plus 3h. We factored out h squared. Should have factored out h squared. So just h and 3. Does that make sense? So always what they have in common as you look at that. So now I'm looking at that next one, Kylie, from the last two. And I'm going to have a plus what?
2
Plus 2.
times 2h plus
2h plus 3. So those look the same again. So Gavin, I'm starting writing, and I have the 3h out in front.
yeah, and we have 2h plus 3.
Okay, they both had that in common.
And then we have h squared plus 2.
H squared plus 2. Again, if it would have been like h squared minus 1, we could factor it further because that'd be a special case. But h squared plus 2 doesn't have anything in common. This is our answer. Now, the reason we are going to be factoring a polynomial like this is in our next unit. We are going to be looking for what's called the roots or the solutions. And those are always going to be our x-intercepts. And all of these, if it is a 4th degree polynomial, will actually have 4 possible solutions when we look at solving it. It will cross the x-axis, like if you put this in your graphing calculator with x's, you would have it crossing the x-axis 4 different places. Those are the solutions that we're going to be talking about. Okay? So, the last two that we want to be factoring, and then kind of some hints. So we start off, and if we are doing this one as we start off, Josie, greatest common factor to everything. 4 and q. So if I factor out a 4 and a q, Liz, I'm going to be looking at okay. Ben, you ready? First two, what do they have in common that I could factor out?
Q to the second.
So I keep that 4q. Q to the second, leaving us with, Ben?
Q to the first. And
Q minus 2. Cassandra, I'm looking over here at this last one. What do I factor out? Plus 3, leaving us with? Yep. So Evie, got the 4q in front, and then what? And just so you are aware, when you look at those answers, remember it does not matter what order you put them in. So if you had them in this order, or if you put the q squared plus 3, if you see this answer in the back, these are the same answer, right? Because you're multiplying all of these factors together, so it doesn't matter the order. But a lot of time we'll put our coefficient with the variable, we'll put that first, And then these two, I don't care. It's never going to be wrong if you have them switched around, okay? So if we are looking, Emmy, in that last one, we're going to start off, and our greatest common factor, do we have something common to all? 2x. So we have 2x, and as we factor that out, Abby Lynn, we're going to have what?
X cubed minus 7x squared minus x plus 1.
Okay, Kate Zimmerman. Greatest common factor of my first two. Okay, leaving us with x minus 7. Common factor to the next one, Elena. -1. Because it has to be x minus 1, right? Or x minus, so it should be x minus 7, right? I think you said x minus 7, I didn't write that. So now we get x minus 7. Okay? So I keep my 2x out in front. Anyone want to volunteer what I'm going to have to write down? What am I putting down next? Go, Liz, and then Elaine, you can up to the next part.
2x, x minus 7, x squared minus 1.
Okay? 2x, x minus 7. Lainey, can I finish it? Is it done? Do I have special case? Do I have a squared minus b squared left in the parentheses? Isn't 1 a perfect square? Isn't this x squared minus 1 squared? 1 squared is not 2, right? It's 1. So I have to factor this one step further because I have a perfect square. I have a difference subtracting 2 perfect squares. So I have to go one step further. So if you stop at this point, which is where a lot of people will stop on the test, you're doing your homework, make sure you're checking that, oh, x minus 1, x plus 1. It is this whole big thing for my answer, okay? I have to go one step further, so you have to watch and recognize those perfect squares. And it just, like some of you are finding, it just takes practice doing them. I mean, you just got to do them over and over, and you see more of them, and you're like, oh, now I see that. I see the perfect square. I see the pattern. You don't practice it, it's kind of ugly. And so use your calculators and look at it. So key thing with factoring, always look for that greatest common factor first. Variable, make sure you include the variable with it. If it has 2 terms or 3 terms, look for the difference of 2 squares, right? Difference of 2 squares, that is your a squared minus b squared. Perfect square trinomial. That's the a squared plus 2ab or minus 2ab plus the b squared. Or a pair of binomial factors. That's where you can just factor like we did at the beginning, x squared, like we just did our 2 parentheses. Polynomial has 4 or more terms. Group them to find common binomial factors. For the final check, make sure there are no common factors other than 1. No common factors other than 1. And this one, some people go, oh, there's only 1 as the common factor, but it can be split, so you just got to watch for that, okay? So, tonight as you are looking